Hello, everyone. Welcome back to Mr. Graham's quick 5 minute or near 5 minute videos. Let's get started with what you're going to be learning this upcoming week. If you couldn't guess just by looking, we're going to be talking about area a lot. And not just in some cases, but in multiple cases. I'll show you what I mean. First, let's worry about the area of this rectangle. Yes, this is a rectangle. It's four sides. The opposites over here being the same, and these opposite sides being the same. They ask for the area, and all you have to do to make sure that you get that is multiply one side by the other different side. You wouldn't multiply this side by this side over there. No, you would multiply these two lines that are what you call perpendicular. They make a right angle. Anyway, multiplying isn't so tough. 21 times 13. Now, if you're a fifth grader, you should already be really good at this. If you're a fourth grader, make sure you don't forget that when you multiply, you might want to make the turtle. See that purple turtle head I just made? And do 3 times 1, which is 3. 3 times 2, which is 6. Have your turtle lay an egg. That's a 0. 1 times 1, that is 1. 1 times 2, that is 2. And after all that multiplication is over, you get to add it all up. 3 plus 0 is 3. 6 plus 1 is 7. 2 plus nothing is 2. Final answer, 273 inches squared. The inches comes from right here because that's what we're dealing with. And when you're dealing with area, you want to make sure it's inches or something squared. Let's move on to the area of this triangle. Area of a triangle is very similar, but a little bit different because I want you to see that if you had two triangles and we put them kind of on top of each other, it would make a rectangle, wouldn't it? Like this is one triangle, this is a second triangle, and together they make a rectangle. So all you'd have to do is multiply, just like we multiplied before. But wait, a triangle is not a rectangle though. No. It's like half of a rectangle. You don't have this whole other area. You just have like a rectangle almost split in half. So you still multiply 5 times 8, which is times tables, 40. But when you're done, you have to divide by 2. Because you're not dealing with a whole rectangle. A triangle is more like half a rectangle. A triangle is more like half a square, or even half a parallelogram. Anyway, 40 divided by 2 is 20. So the area of this triangle, 8 times 5 equals 40. Divided by 2 equals 20. 20 feet, it says feet over there, feet squared. Let's move on. What is the area of this shape? This shape's a little bit different. It's almost like a slanted rectangle. It's called a parallelogram. What you want to do is simply multiply the side, the base, the bottom, times the height. The height of this parallelogram is right here. Never confuse this diagonal line for the height. The height is always a straight up and down line. For a parallelogram, you'll often see it going up straight through the shape. Anyway, it'll be 23 times 14. We can do that, and since we're dealing with slightly harder multiplication than just times tables, you'll need to use the turtle. Turtle head. 4 times 3 is 12. Carry that 1. 4 times 2 is 8, plus the 1, 9. Drop a turtle egg. 1 times 3 is 3. 1 times 2, 2. Let's do some addition. 2 plus 0 is 2. 9 plus 3 is 12, and you'll want to carry the 1 from the 12 over here. 2 plus 1 is 3. Happy day! 322. 322. What does it say right there? It says MI. Is that miles? I'm not sure what MI is, but if it's miles, that's a big parallelogram. 322 mi squared. Simple. Simple, simple, simple. Here's a word problem where every little bit of it's kind of like a clue. Please pay attention so you know what to do. I didn't mean to rhyme, I just happened to. A beach volleyball court is 18 meters wide. 8 meters wide and 18 meters long. What does that mean? We can draw that. 8 meters wide and 18 meters long. So let's see here. It's long is like the up and down. So it's 18 meters long, and wide is the left and right of a rectangle. 8 meters wide. And they're talking about a beach volleyball court. So think about what volleyball courts look like, and that will kind of make sense to you. Like, oh yeah, a volleyball court's like a big rectangle, kind of. I see. And it's 18 long and 8 wide. All right, thanks. Anyway, the rope used for the boundary line cost $1 per meter. How much would it cost to buy a boundary line for the court? So the boundary line is the perimeter. It's the line that goes all the way around the whole rectangle. And it costs $1 each for each meter. So all we have to do to figure out how expensive it's going to be is figure out the perimeter and then multiply it by 1, because that's how much it will cost. So the perimeter is 18 plus 18 plus 8 plus 8, because we're not dealing with area anymore. Area is the multiplication one. Perimeter is the adding up all the sides one. 8 plus 8 is 16. 18 plus 18 is 36. And then we'll add those together. 6 plus 6 is 12. Carry the 1 from the 12. 1 plus 3 is 5. And since the perimeter is 52 meters, and it's $1 per meter to create that boundary line, it's going to cost us $52. Or I'll just write the dollar sign. Dollar sign. There you go. That's the answer. That wasn't so bad. You just had to figure out that you had to find the perimeter. Look at this multiple choice question. Look at the segment shown below. It's not an area or perimeter question. It's somewhat related to perimeter, but a little bit different, because you have to imagine that this line segment they're telling you to look at, it's like one piece of a square or rectangle. And then they ask you, what is the length of the line segment? And you're like, well, usually wouldn't they have like a number right here telling me the length? Like a number right there? Yeah, usually they might. But in this case, you have to see that we're on a graph with ordered pairs. You remember ordered pairs? And in order to find the length, all you have to do is find the numbers in the ordered pairs that are the same. Like, oh, here's a 1 and here's a 1. And you can go ahead and kind of ignore those. And then look at the numbers that are different. A 6 and a 2. And in order to figure out the length of this line segment, just subtract 6 minus 2. That will give you what this length is. 6 minus 2 is 4. The answer is C. Don't forget, that'll definitely show up on a benchmark test, a question like this. Let's look at your pop guide. I want you to find out which statement about these two figures is true. And these are the statements right here. I want you to find the area of this shape, the area of this parallelogram. I want you to tell me how you would figure out the length of this line, the length of this one little line right here. And if you're not sure how to do any of this stuff, rewatch the video, because there's clues all in there to figure out these 4 problems all on your own. Alright guys, that's all the time we have for now. I'll see you next time. Bye-bye.